Your brain is lying to you right now. Every sight, sound, and feeling you experience is not reality, it's a story your brain tells you. Scientists call this the brain's prediction machine. And once you see how it works, you'll never trust your own eyes the same way again. Here's the secret: your brain doesn't react to the world. It guesses what's coming next and then checks if it got it right. That guess is what you actually experience. Think about that. The world you see is just your brain's best guess. A famous study by Carl Friston in 2005 showed that the brain minimizes prediction error to understand the world. That idea is called the free energy principle. This isn't just a fun fact. It affects everything you do. When you study for a test, your brain is predicting which facts you'll need. When you're scared of a spider, your brain predicted danger before you even saw it clearly. This prediction system kept your ancestors alive. If you heard a rustle in the grass and waited to see if it was a lion, you'd be lunch. So your brain evolved to guess first, check later. The problem is, in today's world, those guesses can be wrong. And those wrong guesses can make you anxious, forgetful, or even trick you into believing things that aren't true. Understanding this one idea can change how you learn, how you handle fear, and how you see yourself. A 2010 study by Egner and colleagues used fMRI to show that the brain's visual cortex predicts images before they appear. You've probably done this. You walk into your kitchen and you don't think about where the fridge is, you just know. Your brain already predicted it. That's great for kitchens. But here's the problem: the same system that helps you find the fridge can also make you afraid of things that aren't dangerous. Imagine you got stung by a bee once. Now, every time you see something small and buzzing, your brain predicts pain. Even if it's just a fly. That prediction happens in a part of your brain called the amygdala. It's like a tiny alarm system. But sometimes it rings when there's no fire. And that can make you feel scared for no reason. A 2006 study by Phelps and Ledoux showed that the amygdala learns fear associations in milliseconds. A lot of people think the amygdala is just the fear center of the brain. And that makes sense, because it was first discovered in studies on fear. But here's what they miss: the amygdala doesn't just process fear. It processes anything surprising or important. A funny joke, a sudden loud noise, a delicious smell, all of those activate your amygdala. It's a relevance detector. It asks, is this important? Should I pay attention? When it says yes, your brain starts predicting what happens next. So the amygdala isn't just about fear. It's about learning what matters. And that changes everything about how we understand emotions. A 2014 study by Cunningham and Brosh found that the amygdala responds to both positive and negative stimuli equally. You might think your brain works like a camera, just recording everything you see and hear. That makes sense, because it feels that way. But here's the surprising part: your brain doesn't record the world. It builds a model of the world and updates it when it's wrong. Scientists call this predictive coding. Every moment, your brain makes a prediction about what will happen next. Then it compares that prediction to what your senses actually detect. If there's a mismatch, it updates the model. That feeling of surprise? That's your brain realizing its prediction was wrong. So you don't see the world. You see your brain's best guess. A 2018 study by Seth and colleagues showed that interoceptive predictions shape our conscious experience of emotions. Scientists have tested this idea using brain scans. In one famous study, researchers used fMRI to watch people's brains while they saw images. They found that the brain's visual cortex lit up before the image even appeared. The brain was predicting what it would see. Then, when the image appeared, the brain checked its prediction. If it was wrong, a different area, the anterior cingulate cortex, sent an error signal. This is called prediction error. It's how your brain learns. And it happens all the time, even when you're not aware. In 3 minutes, you'll see the one mistake that destroys even people who know all of this about memory. But first, know this: every time you learn something new, your brain is literally rewiring itself based on these prediction errors. A 2010 study by Egner et al. Used fMRI to demonstrate this predictive activation in the visual cortex. Think of your brain like a video game engine. The game doesn't render the whole world at once, it only renders what you're looking at. Your brain does the same. It builds a simplified model and fills in details later. Here's how it works in 3 steps. Step 1. Your brain makes a prediction based on past experience. For example, if you see a doorknob, your brain predicts it will turn. Step 2. Your senses send data, you feel the metal, see the shape. Step 3. If the prediction matches, your brain learns nothing new. If it doesn't, say the doorknob is stuck, your brain sends a prediction error and updates its model. That update is what we call learning. And this happens for everything: walking, talking, even recognizing your friend's face. A 2015 study by Clark described this as the brain as a prediction engine. Here's the part almost nobody notices: your brain's predictions are so fast and automatic that you don't realize they're happening. And that leads to a huge mistake: you think your memory is a perfect recording of the past. But it's not. Every time you remember something, your brain reconstructs it using predictions. It fills in gaps with what it expects. That's why 2 people can remember the same event differently. Your memory isn't a video. It's a story your brain tells itself, edited by your predictions. And every time you recall a memory, you change it a little. This is called memory reconsolidation. It means your memories are not fixed. They're updated every time you think about them. A 2015 study by Nader and Hart showed that memories become labile when recalled, requiring reconsolidation. So how do you use this? 3 simple steps. First, when you're learning something new, test yourself often. That creates prediction errors, which force your brain to update its model. Second, space out your practice. Don't cram. When you revisit material after a gap, your brain has to reconstruct the memory, making it stronger. Third, connect new information to what you already know. Your brain is better at predicting when it has a good model. By linking new facts to old ones, you give your brain a head start. These techniques are backed by decades of research. And they work because they align with how your brain naturally learns, through prediction, error, and update. Now you know the secret. Your brain is a prediction machine. And you can train it to make better predictions. Start testing yourself today to see the difference. Let's recap what you learned. Your brain is a prediction machine. It guesses the world instead of recording it. The amygdala acts as a relevance detector, not just a fear center. Predictive coding is how your brain learns through prediction errors. Memories are reconstructed, not replayed. And you can use these principles to learn faster by testing yourself, spacing practice, and connecting ideas. Now you know how your brain really works, and you can explain it to anyone. 97% of people never figure this out, but now you're part of the 3% who understand. If this helped you understand something new, hit like so more people can find it. Drop a comment: what surprised you most? And subscribe to join the curious minds who want to understand the world a little deeper. Thanks for watching.